vertices in the middle of it. Okay. For part B, tree with 7 vertices and 7 edges. Okay. So how do you guys do that?
Not possible.
Not possible. How come, John?
Because the tree with n vertices has n
Yep.
edges.
N vertices and n minus 1 edges. Okay. Just in case I didn't say it, make sure you always go back to the definitions at the top. Ensure that what we have as the definitions works for whatever you're trying to do. Okay? So that's why I do it for you guys. So, not possible. Okay. If it has 7 vertices, it should have 6 edges. So 7 vertices implies 6 edges. At least for a tree, right? For other graphs, then that's not necessarily the case. Although it could be, but it doesn't necessarily have to be the case. Okay. Guys, any questions about those? Okay, really easy. For letter C, maybe not so easy. Okay, this one does work, by the way. Okay, we have a tree with 11 vertices, 10 edges, total degree of 20. 3 vertices must have degree of 3. Okay. So certainly this one's a lot more difficult, but it is certainly possible. Okay, so I'll start you out. How nice of me.
Oh, gee, thanks.
I know. You're welcome, Tom. Not a problem. Anything for you, buddy.
That was the hardest part.
It was. Sometimes the hardest part is just getting started, right? All right. So any suggestions as to perhaps how we can do this? So,
I was gonna say, could you make like a line with stems that come down to get those extra curves?
so like, and then branch off of this one, Jacob, or?
Well, I could just going across and then going down. I don't know if that would work.
Well, remember, you have to have some of them that have a degree of 3. So,
Yeah, so I had,
3 of them with
so I
3
kinda,
lines.
like on A,
Okay.
that middle point,
oh, this guy right here?
yeah.
Okay.
Well, I just did like what you had on A in a straight line.
Okay.
I just had one that branched down.
Oh, I
so
see.
that had
Okay.
curves.
So like this,
Yeah,
and then this guy right here, like that?
yeah,
Okay. And then you just kept having like more of that stuff?
yeah.
Okay. So we just had, and then another one that branched down, sir?
Mhm.
Okay. And then another one that branched down?
Yep.
Okay, because that would give you your 3
Yeah,
vertices
yeah.
of degree 3. And then you finished it off like this, sir?
Yeah, just make sure that I had enough edges and vertices.
Yeah, because it doesn't necessarily say like how many degrees, 1s and 2s that it has to have. Okay,
Couldn't
so,
you have also just started with 3 vertices having a degree of 3, so just draw 3
Yeah.
different sections and then connect those?
sure, there's a number of ways to do this, okay? Unfortunately with this stuff, guys, there's no algorithm, if you would. You kind of have to do the trial and error that Mr. Purvis did with that, so that's, if I look at this, I have degree 1, 2, 3, 3, 3, so at least that makes sense. Degree 1, 1, 1, 1.
There are total 9 vertices so
Except
far, right?
that's only 9.
Yeah.
Okay, so we'll just draw one more, right?
You gotta go, yeah.
Okay. So we'll draw one more. So this guy now has a
Whoa.
degree. Does that work?
Except that's 10 vertices. You need one more vertex.
Okay. So
Yeah,
we'll
you
just
need
draw
one more edge.
Okay,
And another curve.
There you go.
okay. Oh, I see what you're saying, Jacob. Sorry, I just didn't go out enough. Okay, so this will be a 2 and 2. Okay. Let's see if this works out. Hopefully it does. So 2, 5, 8, 11, 13, 13, 3 is going to be 16, 17, 18, 19, 20. So, it looks like a dog with a really long neck, I guess, and 3 legs. Or actually it has 4 legs, just no tail. Poor guy. So it's like a giraffe dog. So, I don't know, what dogs have long necks? Snoop Dogg? Oh, it's Snoop Lion, isn't it? My bad. I forgot. So, he changes it every week.
Does he really have a long neck?
I don't know. Questions I can answer, guys? Okay. Construct all non-isomorphic trees with 4 vertices. Okay. Now, remember we talked about what it means to be non-isomorphic. Okay. One vertex has a unique degree, different number of vertices. 2 graphs have different degrees. So we should always ensure that we go back to this when we talk about non-isomorphic. And these are basic cases. Okay. So we need to have 4 vertices. Okay. What's probably the most basic tree with 4 vertices?
Square.
That's not, no, that's
No,
a
that's
circuit.
not a
Can't-
line.
a line.
A
Okay,
line.
probably a line, right? Can't have a square, right? Because that contains a circuit. Okay, almost a square. Okay, so this is 1.
It's not touching. There you go. So broken square.
Okay.
Busted square. Almost a square.
What's another non-isomorphic graph? Okay, well,
Could you do that?
That's the same thing.
It is.
Donnie, go ahead, what were you saying, like this, like 1, 2, 3?
Yeah.
Donnie, unfortunately, that's isomorphic, because couldn't you just spread that out, just like this, like pull it down? And that would be isomorphic. So, okay, that's okay, that's not a big guess. You're wrong, but it's not a big guess. It's okay. You guys are gonna go with you, at least in front of everybody else. Alright, another suggestion, guys? Alright, how about this? What if I did,
Yeah. That's what I was just thinking.
that's what you were just thinking, got it. Why is that non-isomorphic to the first graph?
One has unique.
Correct, okay? There is a unique degree of 3 in that second graph, isn't there, guys? The first graph has two vertices of degree 2. That has a vertex of degree 3 and 3 of 1, okay? So remember, as long as you have different degrees, then you have non-isomorphic graphs. Okay? Anything else that you guys might think of that might be non-isomorphic to either of those two? It's actually good. Oh, go ahead, you.
Like a plus sign,
Okay.
and then it would have to be degree 4, if you have a vertice in the middle.
So, like that,
Five vertices.
and then we can only have 4 vertices, so it would have to look like that.
That's.
But that's actually the
That's the same
distance.
thing.
Because if you just flipped it over,
Yeah.
so, that's okay, it's not a big guess, but that's not it. There's actually no more, okay? Because remember, a tree has to be connected, okay? So at minimum, okay, you can have degree 2, okay? And then you can just work from that. The way that I usually work it is I start with degree 2 and then go to degree 3, then 4, then 5, etc., depending on how many vertices I have to work with, okay? Basically exhaustion, if you would, okay? Does that make sense, guys, with these? You just go ahead, start with vertices of degree 2, and then try to draw one that has degree 3, and then draw one that has degree 4, and then one that has degree 5, etc. Okay, just depending upon how many vertices. Okay. What is the total degree of a tree with n vertices and why? Okay. So this might be a tricky question. Okay. But there might be an easy way to be able to try to figure this out. Okay. Now I'm not asking you guys to prove it. I'm just asking you guys how many there are. Okay. Wouldn't it be good for us just to draw something like each of those and figure out the degree? Okay, so if the total degree of a graph is 0, okay, or a tree is 0, okay, guys, what does a tree with degree 0 look like?
Just a point.
Just a dot, right?
The-
Just a dot. Okay, so that has degree 0. Okay. Let's say we have one vertex. Okay. Oh, actually no, it's like that. So degree would be 0. Degree 1, so this has, let's do this. Let's have a column here. So we have vertices, okay, and we're going to have our degree. Okay. So if it has degree 0, I'm sorry, if there's 0 vertices, then the degree of that graph is 0. What's the degree of a tree that has 1 vertex? 0, right? Remember what degree is. How many sticks are sticking out of it, right? So it's okay. That has no degree. Okay. Let's say we have a vertex of degree 2, or 2 vertices. Okay. Well, I just told you. That would be 2, wouldn't it, guys? Okay. Does that make sense to everybody, guys? I'm just figuring out, this has 1, this has 1. Okay. Let's say we have 3. Okay. How many, what's the degree of that graph?
2.
Nope.
No.
4.
4.
1,
4, yeah.
2, 1. So that's 4, right?
Oh,
Does that make sense to everybody, guys? Okay. If I have 4 vertices, what's the degree of that graph? 6. Okay, so that would be 1, 2, 2, 1, which is 6. If we have a graph of degree 5, it's almost like we're using what, guys? The method of iteration. It's almost like we just learned that for some reason. Like I'm trying to connect ideas to you.
What?
Yeah.
Whoa.
Yeah. So this has a degree of what, guys? 8? we'll just do one more because I think most of you might be able to figure out what's going on with this. Okay. If I have 6 vertices, 6, we have 1, 2, 2, 2, 2, 1, having degree 10. So, if I wanted to figure out, now notice I'm not adding these up, okay? It's not like what you guys just handed in for homework, okay? I'm not adding these up, I'm just trying to figure out the total degree of a graph with n vertices. Okay? Does anybody think they might know what that is? Just looking at what we have there and matching it up to the number of vertices?
2n minus 2.
2n minus 2, or if you factor in 2n minus, or 2 quantity n minus 1. Nice. So we could have 2 quantity n minus 1, which is the same as, John, you said 2n minus 2, correct, sir? Very nice. See if that works, guys. Throw in something that like 3. 2 times 3 minus 2 is 4, okay? 2 times 6 minus 2 is 10. It looks like that works. And guys, doesn't it make sense every time that you add an edge, aren't you increasing the graph's degree by 2? Okay? That you could prove that very easily by mathematical induction, okay? For this graph, we're just going to say that that's what it is, okay? But we're not going through and trying to actually prove that on this. By the way, this is only true, right, if n is greater than or equal to 2, right? Or actually greater than or equal to 1. Yeah, it'll work. Okay? It doesn't hold for 0, okay? Because then you get a negative 2, which just doesn't happen. Okay. So we always want to make sure that we put a domain on this. Okay. Any questions about the graph theory stuff, guys? Okay, hopefully not too difficult. Hopefully it's probably some of the easiest stuff in the course. Okay, so this is it that we have to learn. Okay, so remember on Monday, guys, that if you have some questions about the final exam, we're going to answer those questions. Make sure you bring me some questions that you might have. A good way to study for the final is look at the old examinations. Okay, I have the solutions posted online, so you guys can do that.
Are you gonna do a practice exam or not?
There's one posted online.
Okay, I
Yeah.
have it online.
So yeah, look online, download the practice exam, see if there's problems on there that you guys just can't answer. Okay, if there's problems on there, those are the ones that you want to ask me about. Okay, if you can answer everything, then good for you. Okay. Oh yeah, we'll talk about the reference sheet. It's going to be more than just the note card because obviously it spans 3 examinations plus new material. So, if you want to bring your old note cards, that would be fine with me, and then just make one more note card. That I don't have a problem with that.
So
Okay.
you can make 4 note cards, I guess.
Yeah, I guess that would be fair. Okay. I don't have a problem with that because I mean that's what you guys needed for each exam. That should be good. Okay. Other questions I can answer for anybody about anything? Okay. All right. So I'll be here for a few minutes if you guys need assistance with anything. If you didn't give me your assignment, now is the time. Actually, 3:15 was the time. So make sure.